Okay, so let's see. That's microphone number 1. Does it work? I think it should. Hopefully not clipping. Okay, so let me move to the workbench. I can't continue typing, obviously, but thanks for joining, Andy. Okay, so that's the other microphone. Looks, I don't know, is it clipping? I don't think so. So I can start. Okay, so I got myself a complete capacitor kit from eBay because I didn't manage to order all the parts from some other distributor. So pay the premium, but you get it all nicely packaged. I can put the seller in to the video description after the stream. And I got my peak ESR meter. I mean, not strictly necessary because I anyway have to replace all capacitors after all those years, but still I would be interested how bad they are, or so I got that as well when I ordered the LCR45. So here I have 2 test capacitors. Let's have a quick look. So this is a no name BP 85 degrees 10 microfarad 50 volt, and again it's a very nice idiot proof device. You know, just clip it on, press the button and wait, and it tells me, let's see if you can see that, it tells me 9.78 microfarad, 0.48 ohms. So probably still good. And then just for fun I grabbed another one out of my parts bag. Very tiny. I think it's also 10 microfarad. Some no-name Chinese brand. I don't know, can't read it, but I think that one is worse, just for comparison. And it says 9.85 microfarad, 2.4 ohm. Still usable, but yeah, I mean, in order to really know if a capacitor is bad, you have to know the brand and then go to the manufacturer site and check it. So here I have all my nicely packaged SMD and electrolytic capacitors. Here I have the list, components, and I also printed out from the service manual of the TS-50 which capacitors and where they go. So yeah, I think first exercise would be to open the TS-50. So let me put that out of the way for the moment and grab the radio. Yeah, it's I'm a bit close here with the camera, but I think if I'm too far away, it's also not good for the SMD components. So got an empty tin for the screws. So let's open it up, and I think I start with the front panel capacitor first because that's the easiest one, and then maybe go PCB by PCB, and let's see how far I get in 1 hour. I'm not sure how interesting that is anyway for people watching, but hey, what else do you do? Watching TV all the time between the years. I really have a problem. I'm stuck on the couch and then I do nothing. So it's a good thing that I forced myself to do this. Okay, so I think I have all screws from the top side. Let's see if, yeah, I get it off. I have not disassembled this thing completely, but okay. So Already looks quite nice. It had a CW filter, and I think you can also get a TCXO replacement, and I even saw an interface for for the IF output, so that you can put a RTL SDR on and have your waterfall on the computer. So I don't know how much I will do. First, let's get it into good shape and then see if I'll do any upgrades. Okay, I think I'll also take the bottom cover off. And now I'm about 2 meters away from my streaming PC, so can't really see if anybody is chatting, but I will walk back and have a quick peek. So yeah, I think this was the radio that I wanted when I first got licensed. So when I got my DL license, where you are allowed to go on HF, this is the one I wanted and couldn't afford, so now I got it from eBay. Okay, yeah, something has happened here on the back. I think whoever owned it first, there was something glued on there on that chip, so I can't read the markings on the chip anymore, but I think it was maybe a, I don't know, a USB cut interface, or you know, some TTL to USB converter here that somebody removed when he sold it on eBay. Okay, so let's get the front panel off. I think the first thing you should do is, let's see, maybe loosen this here a bit and take the top screw out, and on the other side as well. Because the speaker is on this hinge thingy, and I think when you, yeah, you can, now you can angle it and take it out. Where is it connected? Down there. Gently, don't want to break it. Somewhere it's stuck. Now, okay. Try not to rip any connectors. Those are sometimes a bit tight. Let me see. I think it's, now I got it. Okay, so that's the speaker. Okay, so now to get the front panel off. I hope the autofocus of this thing is working. I think you just have to disconnect the ribbon cable on the bottom. Gently. I should wear my ESD strap, but then I can't walk to the PC anymore. Let's do that first. Quick sneak peek onto the chat. Okay, no questions, and I didn't break anything yet. So where's my ESD strap? Here. Good. Maybe get the watch off. Don't need the watch. So 2 more screws. And of course that will take more time than just 1 hour live stream to do, but I thought I'd give it a start. And so And there's more cables connected here. So what do we have here? Okay. Somebody already did a LED mod. Can see here. Actually quite nicely done, I must say. Okay, I would have maybe used SMD resistors, but nice solder connections, nicely done, so nothing to complain about here. Okay, so now I have 3 connectors here. Do I have to mark them? Well, the one is 3-pin, the other one is 4-pin, and the third one has 5 pins, so I don't think I can mess them up, so I don't have to mark them. Let's try to get them off. Number 1. Come on, gentle. Number 2. And number 3. And if we're lucky, I can get it off now. Ta-da! Fantastic. Okay, I said I wanted to start with the front panel, so let's put that away for the moment. Preferably somewhere where I don't kill it by electrostatic discharge. Maybe like this. Okay, so yeah, one capacitor here. I think this should be doable without disassembling the whole front panel. I got a number of tools to do this, so I got a fresh syringe of flux gel. Then I bought myself, for this repair, another solder roll with lead. In theory, I want to start lead-free with all the stuff, but for this repair, I guess I should use the leaded solder. Yeah, looks all shiny, so I think this was in an area where there was still leaded solder. And then, what else do we get? A solder braid, fine and coarse, and I have two solder irons which I can use in parallel in theory, so heat both sides. I have the heat gun in the back, but with all this plastic around, I don't want to use the heat gun. And also, I don't know if the connectors are heat resistant. Yeah, it could have been that they assembled this stuff and reflowed all the SMD components and then soldered the connectors afterwards, so they might not take the heat and melt. So I'm a bit hesitant to use the heat gun. And as last resort, I got some special solder which reduces the melting temperature. So I already saw there are a few really nasty capacitors very, very close to connectors. So I thought maybe I can use this special solder to lower the melting temperature, and now it falls out. That was clever. Why does it fall out? Because the bag has a hole. Great. That should be the bottom of the bag, right? Oh man. Okay, let's get it back in. But the idea was to, you know, when it's really close to a connector, use that to reduce the melting temperature, and then maybe I can get it off easier. Okay, and there's one more cable in the way, so maybe I can take that out. Why is it bent? This is odd. Why is this bent? This normal? Yeah, I think so. That's the, I don't know, rotary encoder. And maybe it was a tight fit. It looks bent. Okay. So try to get this off as well. Number 1. Is this a connector or just soldered on? Doesn't look like that is a connector. Maybe just tuck it out of the way. Okay, so now we could in theory use our ESR meter, and unfortunately I couldn't get the pliers when I ordered from Peak Electronics. They were not in stock, or I think I ordered from, what was it, ELV Electronics in Netherlands, because already was already imported into the EU. So no custom problems, but they didn't have the pliers, so I have to which one is plus? Probably doesn't matter here with the ESR measurement. So let's try if I can get that on and see if it gives us a value. Yes, it says 47.92 microfarad but 3.1 ohms. Is that normal for that size capacitor? I don't know. But we have a replacement there, so we can measure the replacement. Just have to find the right bag. So C1 is 47 microfarad, 35 volt. Okay, so they replace the 16 volt variant with the 35 volt, which is nice. Here it is. Yeah, looks to be the right size. So I could, in theory, 47. And it's also 105 degree capacitor, which is also nice. So maybe the kit I got was not too bad. I was thinking about, should I use SMD electrolytic capacitors again or not, but then I ran somehow out of time before Christmas, so I thought, yeah, easiest thing is don't take a risk and just use the readily packaged bag. So let's see, what does it tell me when I measure the new one? Okay, well, it's not 47 but 43, but the ESR is much better. Here it says 0.62 ohms, and that one said, what did that one say, 3 dot something. .1. So I guess we'll swap it out. So let's see, how do I do this? Probably with 2 soldering irons and with a finer tip than this. Let's see, maybe, yeah, I like chisel tips, but don't have a fine one. Maybe this one. Let's try with this one for soldering iron number 1, which is a Erza RDS80, and the other one is my trusty JBC. I also have a chisel tip on. And I guess, let's see, oops, flux gently. It's a completely fresh tube, so I will probably make a mess. Maybe I should get a towel. I'm glad that Mr. TRX Bench is not watching this. He would probably get a heart attack. So always like watching his videos, but of course he's the pro, I'm the amateur. So let's see, let's get a bit of flux on to these two pins, and then get my leaded solder. Oops, fresh roll, still glued on there. Come on. Wick my tip a bit. Leaded solder, so much more fun than the lead free. Okay, should I, let's see, try the same with the other tip. I think I set the temperature on both irons to 350 degrees. Yeah. So let's see if that works. Now comes the funny bit. Let's see. Yeah. Yep, I got it off. Hooray! That worked fairly well. So this is the old one, and since I know me, I should probably mark the old one. Otherwise I will accidentally assemble it somewhere else. And that worked fairly well. So I think maybe the road solder wick. Trying to clean this up a bit. Yeah, I think at least with this capacitor I was lucky. There was no damage visible on the bottom, so maybe now is the time to do this to get a few extra years of use out of this thing. And here I have a bit of paper towel to clean off the PCB. And what do you reckon? Looks okay, I guess. Yeah, and now solder the new one. Yeah, I've not done SMD capacitors in a while. So, and another thing that I should remember to do is when I'm taking the capacitors off, to check that the silk screen really matches with the orientation of the capacitor, because I mean sometimes they get the silk screen wrong. I don't know if that's the case with the TS-50, but that would be annoying to, you know, accidentally put it the wrong way around. But here in this case I think you can also see that the negative side here goes here to this fat ground plane, so I'm pretty sure that for this capacitor it should be right. Okay, maybe I should use a bigger tip for this stuff. Let's see, what else do I have? That one, maybe. Yeah, not sure. Let me get the bigger tip in here. And that's also the good thing of this T245 handle. I mean, you can also get, you don't have to buy GBC, but you can use the GBC tips and get a cheaper station. So I really like those tips because it's super easy to change. You don't have to unscrew stuff and, you know, replace the tip, and the heating element and the temperature is all here in this front section, and it's incredible how much power delivery this thing has. I managed to desolder the TC temperature control, TCXO, yeah, I always get it wrong, TCXO of the what's it called? Bloody hell, sometimes I'm I'm losing my mind of my yeah, I wanted to do Oscar QO100 reception, so I get one of these SDRs, blue something, bloody hell, why don't I remember the name of this thing? It's here, and the box is also here, so I can have a look. Ada and Pluto, that's what I wanted to say. The blue box, that's called Ada and Pluto, and that one is super tricky to desolder because it has a really huge ground plane, and I managed to get it off with the JBC, so but it was tricky. So I think there's also a video from Mr. TRX Bench how he takes it off, and he was also struggling, so even for the professionals it's not so easy. Okay, so let's continue. So I have my tip, I wick it, maybe also should I also put some solder on here? Not sure. How should I do this? Yeah, maybe. No, I was okay. And then maybe slide it into the wet, in quotes, wet, hot, melted liquid solder. Just a bit annoying that this doesn't measure at really S47, so it's better ESR but worse capacitance. Oh, I don't know. Anyway, yeah, I know that this would happen. Come on, with a speed like that I will have done exactly one capacitor and then I end the stream. Come on. Maybe it's better to do it manually. So how wonky did I put it on? Pretty wonky. But here's the connecting wire. You don't want to melt that. Okay, I think the one side it's positioned correctly now, and now I have to properly solder it on. Maybe also some extra flux. That's always my mistake. Not enough flux. Watch Louis Rossmann. He's Mr. Flux. There's no such thing as too much flux. It took a few years for me to learn that. Okay, now that will probably go much better. No, not really. Okay, and the other side once more. I think maybe I did not position it evenly, and that was one of the easiest capacitors of all to replace, so there's much more fun ahead, which I hopefully would not film because it's too embarrassing. So there's still a good chance that I ruin this nice radio. I'm not sure if I'm doing a good job. Yeah, that's also the ground connection, right? So I probably have to stay on here a bit longer. Yeah, I think it is on. I think I see a comment. Let me just walk to the PC. Yes, Theodore, it's 6040. At least I ordered 6040. Just I accidentally stumbled over it in the web shop where I bought the ESR meter, so they had it in stock, so I thought, hey, for this kind of repair it's good to stick to leaded solder. Okay, so let's clean it off. Flux, I mean, that I've spread over the whole PCB. Okay, I guess that is number one of this whole pile. So I hope I can get it done until I'm back at my day job on the, I think, 8th of January. So still have a week where I can do a few capacitors every day. And yeah, I think now I can put this connector back in, otherwise it'll forget that I've taken it out, and then the control knob wouldn't work. So of course we could now measure it again. After I heated it up, maybe it's completely lousy ESR. Yeah, I don't trust myself at all. This. A few years ago I recapped Amiga 600 and my old Commodore C64, and that was not my proudest. Okay, 0.57, 44 microfarad. Okay, good. So better ESR is before, bit lower capacitance, but doesn't matter. So that was the front panel. Let's put it out of the way, and maybe I should take it off here. That was C1. Good. Now the question is, which part to do next. Basically I have to take the complete board out because there's also the through-hole capacitors here, and there's lots of connectors, so I should probably put markings on that I know which wire goes where. And this is the bottom side, and I think below here we have the PA. Let's take that lid off just for a change. I need a new jumper. That one has also seen better days. Spent all the money on capacitors, can't afford a jumper. No, just kidding. Number 1, number 2, and number 3. That was the output. Low pass filters. That's what for the different bands. No capacitors there, I think. These bits look like fuses, right? What does it say? It's also inductors. It says L4, L3. And this is the connector for the AGC. So the question is, do I even have to keep this open? How do I get to the power stage, by the way? Right, I have to keep it open because it looks like this is a board that you can take out, and then one level lower you have the amplifier stage. And I anyway wanted to look at the connector. The power connector is super loose. I got it from the seller with the power connector, but it's super loose. So I don't know if it's some aftermarket power cord that I got here that just doesn't fit, or if this thing is just worn out. Would be nice to do a power pole mod for the TS-50. Have here a nice power pole, but not too many adventures at once. Let's first do the capacitors, and if it still works afterwards, then I can get more adventurous. Okay, so maybe I have no idea which would be the easiest board to take out. Probably this one here. I mean, the bottom side here. What's it called? I think that's the option where you can put the TCXO in. Yeah, I think I'll do that next. So first I have to take the CPU with the backup battery out, and as you can see, somebody did the mod to open the band. So this one diode was snipped, or at least snipped on one side. Okay, so let's maybe take this board out. This was one connector, and the second one, and then unscrew it. Number one. Do I even have to unscrew it? Yes, I have. And where's my electrostatic wristband again? Taken off when I wandered to the PC. Anyway, it's not so dry here at the moment, so I should be fine. And take the shielding off. So what's that? Main CPU board. does it say? Kenwood 1992. Okay. Maybe the main CPU board. I don't know. That would make sense because there's the backup battery here for the channels. So how do I take this off? Gently press, and yeah, good. Okay, that should, there's enough capacitors to keep me busy for a few hours here. Maybe I should do the through holes and work up the courage for the next capacitors. Here was also some mod. You see, somebody scraped off the PCB, the green coating here. So maybe there was some ground wire taken for the CAT interface. Okay, right, so do I need to mark anything here? We have 1, 2, 3 RF connectors and 1 connector here. I think I can, there's no danger in mixing those up from the length of the wires, so let's see. Oh, it's all pretty tarnished already. If you look at these connectors, they all got a bit black, but where they were connected into the socket, they're still looking okay. So come out. Number 1, number 2, and number 3. And the odd thing I noticed when I tested it, I have this cheap Chinese ring light here over my workbench, and oh boy, that went straight into the receiver, right? So when that ring light is on, the receive is completely, you know, S9 level of noise. Oddly enough, when I have my IC705 here, or also even the true STX, I didn't have that problem, so not sure. Maybe it's better after the capacitor replacement. Okay. Now I think I should maybe get another box for the screws, otherwise I will never know which screw went where. Let me get another box. Okay, had a peek at the chat. Yeah, Theodore, it's aging. This I don't know if you can see from the serial number for Kenwood devices when it was manufactured, but I guess it's in the 90s, so it's like 30 years old. And yeah, SMD capacitors are known to leak, and then the electrolyte, you know, falls out in quotes, and since it's a bit acid, the big danger is that it chews through PCB traces, and it, when it's really bad when it flows into through-hole connectors like via. Via is where the different layers of the PCB are connected, like here, this tiny little holes here that you see. And if the acid gets in there and, you know, removes the copper, then, I mean, it can basically completely destroy the radio, and then there's nothing you can do anymore. So I must say this one looks quite okay. So I was lucky there. It could have been a complete disaster as an eBay purchase, but this one looks like in okay condition. But if you look on YouTube for TS-50S, there are some really terrible videos where you freak out. Okay, so I got a mint box. I will put all the screws in that one. So, and when I recapped the Amiga 600, I really had leaking SMD capacitors. So that was, and once they start leak, it's also very hard to desolder. I mean, the one I just did here on the front panel, that was easy peasy. Yeah, was no corrosion, just flux heated up, job done. But once the acid leaks out, you really have to first clean off the acid, and then when you solder, it's pretty tricky even with flux. So I don't know. I think it should be done. Of course, there are different different opinions about that. Some people think, hey, as long as it looks good, don't do anything. But on the other hand, you sometimes don't really see it. Yeah, it could start leaking and you don't see it, and once you see it, it might already be too late. So I think, yeah, I think it should be done with 30-year-old devices. Okay, so did I get all screws off, or are there screws under the oscillator? No. Surprise, surprise. I got it off. Huh, lovely PCB. I wonder why they put components like vertical here. Like this looks like something on a ceramics substrate. They put it vertical. So if one of those things dies, then you're really fucked. Excuse my French. Okay. Yeah, maybe let's do the through-hole capacitors first. Let me put that out of the way again. Close my lid. And of course it would be interesting what the ESR meter says, right? Just for fun. So let's check out the through-hole capacitors. That looks okay. 225 microfarad, 0.52 ohms. Looks okay to me. I think the peak makes interesting. For that one, I just want to say the peak tells you basically when the capacitor is bad. I mean, of course, you always have to check the manufacturer side what is really bad ESR, but for this one, for example, it just told me, meep, you don't want that. Why does it say? But it says 0.44 ohm, and it also says leaky. Interesting. Maybe it also depends on the, you have to look at the schematic where this thing is. Of course, when there's a resistor in parallel, or you could get a wrong measurement. Okay, so interesting. Those are supposed to be exactly the same capacitor, right? So this 2 times 220 microfarad. This one says fine, and this one says meh. There's a small SMD capacitor in parallel. Interesting, isn't it? Well, as I said, I will anyway replace all of them, but it's a training exercise. Let's check the other two just for fun. So in theory, you don't need a ESR meter. You just need a replacement kit and just do it. But I was curious if I... Oops, that one is not happy at all. Okay. And am I even in focus with the camera? See, they all say leaky. So, right, let's get them out. But first I have to see what capacitors I need. And this was the 47 one. Where did I take that out? Here. That came out of this bag, so put it back in. And how long is the stream running? If I'm boring everybody to death, I'll end it. What's the time saying? Okay, 55 minutes. Yeah, so I don't know if there's still anybody watching. Yeah, I'll probably work on this for another hour, so I could let the stream run or stop it. Doesn't really matter. So, what board do we have here? This is the PLL board, I think. Yeah, looks like this one. Just swap it. So, and it's like this. Yep. And we want to replace the capacitors. Number C17. Let's see, it's 220 microfarad. C17, C181. So those two. Oops, you can't see it. Those two here, and on the bottom side we have (100 microfarad). Okay, let's do those first here. 220 microfarad, 16 volt. Where are they? Here. Very nice packaged. I was a bit worried because the SMD capacitors came from the UK. I was not worried about the sender, but I was worried about post and customs and problems, but they arrived fine. So yeah, 220 microfarad, 16 volts. Take those two out here. Oops, you can't see it. So take those two out and put these two in. So it's time for more flux and my original US solder sucker manual solder pult. This thing is really great. I have the other manual solder suckers. Let me show you. And none of them work properly. Well, they are like this one. You think it is a nice device, but I think it's maybe just the volume See, and if you hold here, yeah, it does not really seal properly. The solder pult is worth an investment if you want to go for a manual one. Of course, the Chinese solder sucker guns with a motor are also fine, but this thing is really, it's amazing. It just works. It looks like cheap crap, but it works. So go for the original. So then more flux. So at least for the through-hole capacitors, the ESR meter told me they are bad, but I'll be interested once I've replaced them if they measure good in circuit, or if it's the circuit that somehow fools the ESR meter. So good. Where is my... Can you see it? No, you can't see it. Here, just see that? How fantastic this thing is. Okay, that was... So the question is, does it already fall off, or do I have to heat it again? See? Gently. Wiggle it a bit. Yeah, this... The plus side is coming out, ground is here on the left. And the ground side is a bit trickier. Maybe I have to heat it again. I'm not doing a good job here. More flux. But in theory, the through hole should be easy, right? It's the SMD components close to connectors that scare me. Okay, got one out. And I have my ESD strap not on again. And this one, yeah, that's also coming out. Wiggle. Ouch, that doesn't make a good sound, does it? Did I ruin it? No. Looks good. Okay, I got them out, but of course I have two holes full of solder. Let's see if I can get them out. That was not great. That's the only annoying thing. Once the eye closes, no, I got it. It's sometimes tricky to get the solder out of the hole. I think I should have maybe held it more vertical. And yep, that looks promising. Maybe once more. Yep, Hooray, I got them out. Didn't damage the traces. And just for curiosity, let's see if they also measure bad now that I've taken them out. Okay, that one is okay, and if the other one is also okay, then yeah, then it was fooled by the circuit to think that it's a bad one. Sometimes also heating it up revives that capacitor. Anyway, those have to go. Oh, I see lots of text in the chat window. Maybe I should get some glasses on extra monitor here on the workbench so that I can read it. Hang on a second, I have my mobile phone here. I could go to YouTube on my own stream in order to see the chat messages. Yes. Okay. Caught up on the on the comments. And yeah, my priority here is really to not balk the radio, so sorry guys. I just thought it might be interesting to watch. So the stream is not priority number one. Not breaking the TS-50S is what I'm really trying to do. Okay, so I have two new 105 degree rated 220 microfarad capacitors, and I have to get them in the right orientation. That would be helpful. And the second one as well, minus on facing bottom. Okay. No, I don't think I really need extra flux here for the through holes, but why not? That syringe should be enough for this repair. And the cat came to say hello, but I can't show you the cat. Well, actually I can. This is a webcam, so no, it's screwed on. I've screwed it on. Oops, and now it's moving. So yeah, the cat is already complaining that I'm not playing with her. So let's see. Maybe do the plus side first. And I always hate it when you bend the pins outwards and then you solder it. That really annoys me. So I always try to hold it and then get one pin soldered in halfway straight. And of course now it was not really good. I have to heat it again. So see, like this, and then I can straighten up the other one and solder the other one. And that's the ground connection, so that one needs more heat. Oh, not too bad. And then the other one. And of course I'll do the experiment with the ESR meter in a second again, just to see if it was really the PCB environment that confused the ESR meter or something else. So Yeah, I think that needs a bit more solder on that pin as well. And I think when I desoldered it, maybe a tiny bit of solder on that capacitor on the... let me first clip the leads. One, two, three, four. I'm not so old, but sometimes I need a magnifying glass, at least for SMD. I was thinking about getting one of these cheap SMD microscopes. Yeah, maybe it's not so bad. Maybe a bit more solder or reflowing that little SMD capacitor, which is here in parallel to the through-hole electrolytic. Be a good idea. Maybe just a little bit, and number one. And yeah, now I'm happy. Oh, successfully caught some cat hair. Okay, well, that was easy. Through holes are really much easier. Good. So now the big question is, what does the ammeter say now? Still confused by the PCB, or is everything perfect now? Oops, that was... I'm sliding off the... Yeah, it still says in circuit leaky. Why would that be? Any ideas? I mean, that one measured well before, and I swapped it, and it still measures well, obviously, and the other one measured bad. And I swapped it, and it still measures bad, but why would... I don't see... Is there a resistor to ground there somewhere in the vicinity, or... I really don't only see this tiny chip capacitor here in parallel, but that's a ceramic, so that should not go wrong. Interesting. Maybe I have to look in the schematic afterwards. Maybe I find a hint. Okay, so that was C17 and 181. And I have my first bag empty, and I can put the old capacitors in that one. So on the other side we have two 100 microfarad 16 volt, C151 and 239. And I'm blind here. Okay, let's look for the right bag. 100 microfarad. There it is. 25 volt. And I guess I need 2 of those. I think somebody has written a comment to my dumb question why the ESR meter failed. Should remember to take my mobile phone so I can have a peek. Okay. Yeah, hi Bobby, thanks for joining the stream. You think, yeah, I didn't see any leakage, and I've cleaned, I cleaned it off. I will look afterwards in the schematic of the TS-50 why that might bamboozle my ESR meter here. It looked completely dry actually. So anyway, let's get on with it. Do those two more through-hole capacitors, and maybe then how many SMD capacitors do we have here in 3 times 47 microfarad and 2 times, what is that, 1 microfarad or 10, I don't know. Okay. Let's do it like this. I set myself the limit, stop after 2 hours, because after 2 hours my concentration goes away and I make stupid mistakes. So I'll end this stream after 2 hours. How far I get, this is how far I get, and then it's probably best also to switch off everything here and not touch it, because yeah, I know myself, you know, if I keep going then things go bad and then they go worse, and then yeah, you have to know when to stop. So minus is on the board outside here. Yeah, it's really, I think I was, so far it looks like I was lucky with this eBay purchase. So to the guy who sold it to me, thanks for taking good care of it. Okay. I think my other video was probably too boring. The one where I tested the the LCR45. I thought it is a short video, but then it somehow ended up half an hour long. I'm not sure if it has any value. But hey, I had to finish that one first in order to continue with this one. Yeah, only one. Well, maybe not one, but not too many open projects at a time. So that was not good. To get the solder out, maybe fresh solder in, and try the solder sucker again. Yep. Yes, nice. I don't know about you, but I find things like that very meditative. So you're just working along and do something with your hands. My day job is software engineer, so this is like I get into like a zen-like state where I fiddle with PCBs, and I really like it. It's great. I have to do more kit builds in the new year. I thought about getting a what was it? Hard Rock 50 kit, but they're, well, I mean, they're a bit expensive. You could get for the same money, you could get a readily built one. But on the other hand, then you've built it yourself, so that's also what counts. So yeah, sometimes, I mean, kit building, it's about the fun and not about how much money you saved or not. So yeah, maybe I should still get the Hard Rock 50 kit. But now I have the TS-50. I thought I get the Hard Rock for the IC705. But then if you want it with all the options and you think, oh yeah, maybe an ATU, and you know, with all the extras, it all adds up. So and I should concentrate. See, it's already going bad. I almost put the capacitor in the wrong way. Just remembered at the last second. So it's maybe time to slow down here and wrap up before I make any major blunders. It looks fine. And the other side, am I in focus? Yeah, looks like. Maybe a bit more solder. This was the 0.7 millimeter diameter. Maybe I should have bought the 1 millimeter. Okay, so snip, snip. Yeah, so maybe I should try a bit of FT8 or some SSB QSO on 40 meter afterwards. I managed to catch Carl when he did his live stream today. I already like it. I hate this green color, but they used to be green at the time. What was it? Elna capacitors. Okay, and I think those are proper Panasonic ones. Doesn't say so, but the black ones are. I think they're Panasonic ones. Good. One more through-hole capacitor here. More flux. Yeah, as I said, the through hole is really easy. But let me just maybe quickly show you where I'm already frightened of. Like, yeah. The real fun starts like this one. Look at this one. On the one side you have here the clamp for this transistor, and here you have connectors, and here you have connectors. So I can probably get one soldering iron in on this side and the other maybe here. Or maybe I should first take the through holes out, and before I put them back in, do the SMD capacitors here in the middle. But I mean, this area is like, I'm already I already see myself, you know, melting these connectors, and ooh. Anyway, one step at a time. So let's first finish this board. PLL board is also important. It's nice to have a PLL. Oops. So okay, well, I got it. Got the old solder out. More flux. And then a little bit of new solder in, or solder. Not sure what you guys prefer. And then maybe gently wiggle it and try to get it out without breaking anything. Okay, so now try to yep, that worked. This thing is really worth every cent. That's the first manual operated solder sucker that I own in my life that actually works. I've never had one that works before, and this thing is just great. See, no problem. Perfect. And I think there are two variants. Yeah, there's a ESD variant and a non-ESD variant. And speaking about ESD, I again am not wearing my ESD wristband, and I think this is the ESD version because it's black. The other one is like baby blue, or yeah. Okay, and now I have not looked in which orientation the capacitor was inserted. That was clever. Let's see if we can figure it out. It says plus on the top here. Does that make sense? I think it makes sense because the other pin looks is that ground, goes to this side here. Maybe I should look in the schematic, just double check it. I think this was the orientation according to the PCB. Yeah, maybe I should check it. I'm paranoid, yeah. Maybe too paranoid for this world. So let's see. This is called the PLL unit. Do I have the schematic here somewhere? Or did I print it out? That's the question. No, I didn't print it out. The full service manual is a lot of pages. Okay, I have to check afterwards on the computer. But okay, should I trust Kenwood's silk screen marking? Well, for the others they were right, yeah. So what are the chances that this one is wrong? Who knows? It's C239. I should at least bloody hell. I have such a mess here in my workshop. It's incredible. And I don't have a lot of space. This whole desk is like 1 meter 20 times, or maybe 140 times 60 centimeter, and it's cramped with crap. I really need to do something. Maybe I should get a few new benches in the new year. That would be a good project. Get a proper desk with some extra shelf desk space. So what did I want to do? Yeah, I have to check that the plus side of C239 is connected to L203 according to the schematic. Do I have the schematic on the mobile phone? That would be handy. Knowing myself, I don't. Anyway, I'll check it after the stream ends. It's not so hard to swap a through-hole component. So for the moment, let's hope it's right. I'll check it, and yeah, for the SMD capacitors, it would be much more annoying to get it wrong. Good, then. Flux baby. Yeah, this is maybe I should hold it like this. I think you couldn't see it. I'm sometimes out of focus here, sorry, but I'm trying to not mess up the radio completely. No, it's also not super nice. Easy. Don't start knocking off SMD components because you're in a rush. So okay, so we got two 100 microfarad 16 volt out, and we put two 100 microfarad 25 volt in. Plus, 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 plus looks good. Okay. So that goes in my old parts bag. Now, should we do one final SMD capacitor? What does the time say? How long is that stream already running? Everybody's fallen asleep. 1 hour 30 minutes. Okay, not too bad. So let's do It doesn't really matter anyway, I have to do them all, right? That is already a bit fiddly here with the shielding. And the shielding is soldered on. Can I get to it with the soldering iron? That could be tricky here. This one. Yeah. Not good, isn't it? Would you take the shielding off just to be able to replace this one? It's 4 pins in theory. But it's 4 pins soldered to ground plane. So yeah. Maybe this one is better because it has a thin tip. Yeah, that might work with this tip because it's longer. Okay, shall we try that? Let's try the tricky one. If it doesn't work, I have to take the shielding off. Okay, so and also be careful to not melt any connectors at the same time. So let's see, what are my chances of getting that off? Maybe like this. Yeah, that might work. Ha! That was much easier than I thought. Lucky me. That was super easy. Yeah, sometimes you're lucky. Anyway, I just thought about a much easier way how to find out if I did it right. I'm streaming this shit, so I can just, you know, after the stream has finished, rewind and check in what orientation the original capacitor was. So that's probably the safest thing to do. Right, we got one off, but I think they're all 47 microfarad, these 3. So I think I'll take those 2 off as well. And this time I'm checking the silk screen, and the silk screen seems to match with the orientation. So more flux. I think this one is the easiest of all the boards to do. Of course I started with this one to not make a complete fool out of myself. I'll do that off screen and then I'll tell you that I've killed it. Hopefully not. So here we go, another capacitor to gently lift off the board. Let's see. Whoop! Hooray, got it off. Maybe I'm getting better. Once I've done a few, I'm getting better at this. And the third one, let's take that one off as well. And that is again a bit tricky because there's a ceramic capacitor on the other side. So if I, maybe, I think it's doable. Just have to always think how to put your soldering iron or how to orient it before you start frying. I'm using the tools that I have at hand, of course, with one of these SMD pliers where you basically have two heated prongs. It would be just much easier. You just go there and like a pincer and heat both sides and just pluck it off, but I don't have things like that, so I have to use two soldering irons. But maybe it's not the worst way. I mean, compared to using the heat gun, at least I'm only heating the two solder joints I want to work with and not the whole board, so maybe it's not so bad. I just have to figure out which soldering iron and in which hand, and yeah, maybe like this. Oops. Here from the back and here go from an angle so that I don't fry that capacitor, but I don't really see where I am because the yep, good. Okay, so well, I'm much better at taking it off than putting it back on again, I must say. Good. Yeah. Into the parts bag. I should have measured those with the ESR meter as well, right? Just for fun, but now I've already thrown them in. Anyway, for the sake of now I have 4. Oh well, let's just quickly check them, just for fun, how bad they are. Again, no acid on the PCB, so I'm a very lucky man so far. Yeah, I think this was the one from the other board, because it has a different color. Those are all a bit yellowish. So let's see, what do we have here? 3.6 ohm, bit high, I don't know. My idea would be that it should be around 1 ohm, or even below 1 ohm, but I have not really the experience. What about this one? Why does that not measure at all? 3.8 ohm. So also, I think it's a bit high, but 3.2 ohms. Well, they still all have about 47 microfarad, so maybe it's okay. What I want to say is maybe I'm still in time and they are not as bad as I thought. So okay, yeah, same procedure as last time. Just clean off the old solder with the solder wick and put fresh solder on, and then where is my other solder wick? Where have I thrown that in? Here is one. But I think I wanted to use the thicker one. Yeah, so as you can see, I have no idea what I'm doing, but I'm trying. Would be nice to get a few years of use out of that machine. I connected it to the dummy load, and I think it does even a bit more watt as what is on the tin. So I set it to 100 watt and it actually does a bit higher. So I think I'll, after I've assembled it, there's probably some trimmers somewhere where you can get it back into check. So just you know, CW key down and then really set it to 100 watt when it's supposed to do 100 watt. But of course depends. If you're doing SSB, it's probably fine. And my CW is still terrible. I did this live stream a while ago where I said get back into CW, but man, I'm so bad with my numbers. I don't know, everything's fine, but numbers I can't decode numbers. I always get it wrong. I don't know why that is. A lot of people say numbers are so long that you can count, but I'm very bad at counting, so I think I have to brute force it and you know, try to hear the pattern. So I can't count because I always get it wrong. Does it start with a dit? Does it start with the da? So I always, you know, mix it up. I mix up 1 and 9, or 4 and 6, and it's terrible. Yeah, so until I have my first CW QSO again, will take some time. So and 1, 2 more pads to clean, maybe. Right, okay. That was not so. That looks yellowish. Why does that look yellowish? Now it's clean. Maybe I should angle the board a bit so that you can see. The ring light is reflecting really ugly. But hey, I got 3 capacitors off without frying anything else. The tricky bit will be the resoldering. Okay. I'm already thinking, should I already do this today or give it a break? Then I would rather take off those 2 as well and then solder them in after I had a bit of a break and concentrate properly. Maybe I should do that. What do you reckon? Yeah, I think I'll do that. Sorry guys. Or maybe, yeah, I take those 2 off and then I just solder one more SMD capacitor in and then we take a break. Because I already feel my concentration slipping. So maybe taking those 2 off is still easy. Right, let's do that. should have measured them first, shouldn't I? Oh well. Got this nice ESR meter and now I'm not using it. Well, just applied flux. Let's take them out. So. The ASA soldering iron decided it's time for a break and did the auto power off. That can't happen with the JBC. It has a contact in the holder. So when you put your soldering iron into the holder, it goes into a standby mode. So instead of having the tip heated at whatever 350 degrees Celsius, it goes into standby mode and just has a lower temperature, which makes the tip last longer. But the ASA doesn't have that. So, but it's back on, so I can right. Maybe that tip is a bit broad for those two capacitors, but let's see if I can get them off without damage. And silk screen seems to be correct as well. And touchdown and check. And one more. Right. Easy peasy. Okay. Yeah, and the solder wick works also very nicely, but anyway, I'm so used to leaded solder. When I got the lead free, it's, I don't know, it's just it's not bad. I mean, it flows fine and so on, but it's just a bit different. Yeah, you need a little bit higher temperature and you really also need to get used to it. And yeah, I mean, if you used leaded solder for 20 years, and it takes a bit time to get used to the lead free, and also that it gets dull. Yeah, the second it cools down, it gets dull. I think the only way to keep it a bit shiny is you completely have to drown your PCB in flux so that no air gets onto the solder connection. So yeah, I don't know. Leaded is easier. Okay, so we got those two off as well. And nicely cleaned off. Okay, I mean, that's not the point of an ESR meter to measure after you've taken it out of the circuit. The point is to be able to detect the problem while it's still in circuit, but I forgot. I already applied the flux when I remembered. Anyway, quick check. What does it say? Oops. That is really terrible, I think. 10 microfarad, ESR 11.4 ohms. That is really bad, I think. This one 12.6 ohms. So yeah, I think it's really time to do this exercise before they start leaking. As long as they're only drying up, that's of course the preferred way that those things should die. Okay. Yeah. Let's solder one last SMD capacitor in, and then it's time to end the stream, I think. So, of course, I should check what I'm actually putting in here. I think 47 microfarad, yeah, when I remember correctly. We are on the PLL board, and oh, I forgot to cross out the capacitors that I've put in already, so I put 2 more through hole in, and that was C151 and 239. And then I need C119 on the PLL board, and I'm blind and I don't see it. I don't see it because it's on the back side. Here, 3 times 47 microfarad, 35 volt. C80 is this one. C119 is this one, and C186 is this one. So it's the bag that I already had used before, where I put on the one capacitor on the front panel. So let's get one more 47 out here. And which one should I solder in? C119. Let's take the one here at the corner. And again, I'm not entirely sure how to do this. There are 2 different ways how to do this. Maybe first look at the placement. Yeah. I'm still not sure what's the best way for me to do this. You know, first place it, then tack it, and then get really in with the solder, or completely tin the leads and completely melt them and slide in the capacitor. That's a popular method. Like you, let me demonstrate with the screwdriver. Assume this is the soldering tip. You put your solder here on, wick it, so that the pad is completely, has all the solder on. And then you heat it, and then you basically slide your capacitor in from the side. Of course, you need space. Here it would work. Don't know. Maybe I'm over-engineering this all. let's try this. Let's try the slide it into place method. Why not? So first, put new solder on, and also flux. And now, of course, I'm left-handed, so I'm probably should turn the board around. Yeah, but now I can't see it. See, it's also not so. It's not so brilliant, is it? I have to do it with the other hand. So. Okay, so grab this, then heat the pad and slide it into place. Oh, not too bad actually. Worked quite well, and you can check on the other side, which is not yet which is still clean, if you got the placement right. So if you shifted it too far in or not, but it looks good. So now I can put flux on this side and just solder that one in, which is the ground side, which will be a bit trickier. So let's see. Okay. Patented YouTube zoom. Let's see. Can you see that? Haha. Low tech is key. What do you reckon? Good enough? I think it's okay. Okay. And clean off the flux. Also from that side, gently. And I think we have successfully replaced C119, which is this one. Okay. I think it's time for a break. That's always the hardest bit when you're in the flow, to know when there's time to stop. And then I can clean up the desk here a bit and have a fresh go tomorrow. Okay, let me wander back to the screen. And I can also I have a hot air blower, Andy. I'm just too wimpy to heat up the whole board to like 400 degrees and melt the connectors on it. Okay, 1 second. Testing. Okay, so that's the other microphone. I'm back at my check desk, so that microphone should sound a bit better. Okay, so the stream is running almost exactly 2 hours. So I think now is a good time to stop it. Let's see if I missed any other chat messages. Okay, no, doesn't look like. Okay, so I hope that was interesting for you. I think it went quite okay so far. No major accidents, and I think this board is doable. But the one on the other side, maybe I should do that not in a live stream. I should really completely focus on it, because that's, SMD capacitors like 5 millimeters next to connectors that melt. That will be fun. Okay, then everybody who joined, thanks for joining, and I think I'll clean up my desk and try to do some FT8 on 40 meter maybe, or see if I can catch a SSB QSO. So 73, and Happy New Year, of course, to everybody. Bye, guys.